This conference will now be recorded.
Hi everyone, we will now learn more about the concept of regression. Now, in the previous video, we have noted this point. When the data are really so simple, we can guess the regression equation. In this case, the regression equation is y is equal to 2x. And what is the alternative method? We can use a statistical procedure to find out the regression equation. There is one more alternative procedure. It is nothing but the graphical method. But if the data are really little bit complex, see, containing fractional values, containing 4 digits and 5 digits and all, right? The first method, guessing, is not possible. Guessing the relationship between these two variables is not possible when the data are not like this or like this. Even in the case of statistical procedure, if there are 500 values like this, finding the cross product, summing all of them are going to be very difficult, even if you use the calculator. And graphical method is also ruled out because plotting this fraction value is going to take a lot of time. In such cases, we have to use a program. We have to use a program. That is what we are going to see. Now, anyway, first of all, we will write a program. We will write a program to find the relationship between these two variables. When the data are really very simple, right? When the data are really very simple, we can guess. Still, let us write a program because we can learn the basics of programming very easily when we write the program for this simple data. I repeat, first of all, we will write the program for finding the relationship between, right, x and y when the data are like this, and then we will immediately write the program for finding the relationship between these two variables when the data are little bit complex like this. Now let us have a look at the program. Let us have a look at the program. See, there are 5 steps: step 1, step 2, step 3, step 4, step 5. Step 2, step 1, step 2, 3, 4, and 5. Now, see, what is the name of our data set? Salary data 1.csv. How does it look like? See, the name of the data set is salary data 1. How did I create this data set? Very simple. I just open an Excel sheet, type these two headings over here, type these values, stored it as salary data 1. That's all. At the time of storing, I have chosen the format as CSV. That's all. Here, now, suppose someone comes and asks me, I possess 9 years of experience, how much salary I can expect? See, you can very well guess when you look at these values. You take any value, multiplied by 2, you get this value. It's only a fictitious data set. So if you are going to have 9 here the corresponding value is 18. So you are predicting the salary. Suppose someone else comes and tells you, I possess 10 years of experience, how much salary can I expect? And then you can say you can expect 20 lakhs per year as your salary. So we are predicting the value of salary. So this variable is taken as a dependent variable. Please remember this point. Right? You just ask yourself one question: what do you want to predict? Do you want to predict this or this? You want to predict the salary. So that is your dependent variable, right? Identifying the dependent variable is very important in the field of data science. Other variable is known as the independent variable. Now, the value of salary depends on the value of years of experience. When 8 becomes 9, 16 becomes 18. When 9 becomes 10, 18 becomes 20. So salary depends on years of experience. So since it depends, it is known as a dependent variable. Other one is known as independent variable. I have already told you in the last video, dependent variable is also known as target variable. Independent variable is also known as predictor variable. Let us have a look at the program. Now we are reading the data from this table, and storing the data in a memory location whose name is data set. Whose name is data set. Now for reading the data from this table, we use a function known as read CSV. This is a predefined function. The developers of Python language have developed the code for this function. They have developed the code for 100 such functions, and they have collected all these 100 functions, and they call this collection as a package. The name of the package is pandas. Let me explain a different way. A package is a collection of functions. The package pandas has many functions. One such function is read CSV. When I want to make use of the code, predefined code, I have to write this line. What does it mean? When I write this line, what will happen? The codes for all the functions in this package will be moved into the main memory. Then only I can make use of this function in my program. Now, what is PD? It is the shortened name for pandas, right? If I don't write like this, here I have to write pandas.read CSV, right? Now, on the other hand, if I write like this, right, as PD, instead of writing pandas, I can write PD. Now, similarly, I am writing this line in order to make use of this function. Similarly, I import one more library known as a NumPy and one more library known as matplotlib. Okay, so in every Python program, the first part will be always like this. Please remember, whatever I say, I will not repeat in the subsequent videos. And then now we are reading the data set. What does this mean? Now our table is represented by data set. Now what do I tell the system? The salary column in my table, should be treated as a dependent variable. I have told you we use Y to represent the dependent variable. Similarly, the column years of experience, I told you this one represents the data set. This one represents a data set or table. Years of experience in this table. This column should be treated as an independent variable. I have told you we always use X to denote the independent variable. So first of all, I read the data from this table and then tell the system what is my independent variable, what is my dependent variable. This is a very crucial step. And then this is, see, I will explain every line, but this is the heart and soul of this program. Now, what do I say? This is one more, right, predefined function. I told you this is one predefined function. There is one more predefined function. It is available in this package. What does it say? It will find out the regression equation between X and Y. I have told you regression equation is also known as prediction equation, right? It is nothing but the functional relationship between X and Y. So this function will find the functional relationship between X and Y by using an algorithm known as linear regression algorithm. So for sorting a set of values, we use either heap sort algorithm or quick sort algorithm or some other algorithm, right? So so many algorithms are available for sorting a set of values. Similarly, this algorithm, let us not worry about the algorithm. Algorithm is nothing but a procedure, a collection of steps. So once we find the relationship, we can use it to do prediction. We can also represent the relationship between X and Y in a graphical form. When I execute this program, I will provide much more explanation. Now, let us execute this program. Let us first of all copy these steps, right? We will execute the programs stage by step, copy. Now I am going to execute by using an online, right, online lab facility known as Google Colab facility. Now click it, right? You will get Google Colab facility. You have to click new notebook if you want to do a new Python program. Wait for some time, right? Let me paste the code. Now we need the help of the data set salary data one. So we have to, right, upload it. Click this symbol. Wait for some time. Click this symbol, upload symbol, and then which data set we are going to use? right? Salary data one, salary data one. Click, select that one, click open, right? They say it will be available only as long as this session is live. Once you close the session and come back, you have to upload it once again. Now, once you upload it, you can directly refer. Now, let me execute the code. Let me not waste any time. So I am importing the libraries. I am getting data from this table, and then I am defining the independent variable and dependent variable. When you move the mouse over here, you will get another code block. Now let me go back and copy some more code. Let me go back and copy some more code, right? And paste it over here. Now what am I doing? I am finding the functional relationship between x and y, that is nothing but the regression equation. And then I am finding the regression coefficient. I told you, right? What is the regression equation? Y is equal to 2x. Y is equal to 2x. This is my regression equation. Now the number that you have before x, nothing but 2, that is the regression coefficient. That is known as the regression coefficient. See, my program has correctly found out the value, So I'm really a very happy person because I know that my algorithm really works very well, right? Now I will go back and copy the remaining code, right? This code is not so important, so let me skip it, and then let me come back. I'm going to visually represent, right, the regression between x and y. They say there is some problem. What do they say? Y pred is not defined, they say. So we have skipped some code, that is used over here. See, y pred, predicted value, used over here. So we will execute the whole code, and then there will not be any problem, right? Come back, say we will not worry, right? So we will take another block, we will paste it, and then execute it. We will get the wonderful picture. You see, this is a graphical representation of the functional relationship between y and x. You extend this line, you get to see extend x-axis. 9 will be somewhere here. Draw one perpendicular, draw one right parallel line, and then you will get 18 as answer. So now you have an idea about the program that you write for linear regression. Step 1, you read the data. Step 2, you find the functional relationship. Step 3, you represent it visually. Thank you very much.